Okay, if you guys could go ahead, put away your homework that a lot of you have started on. So put that away. You can put it in your homework section. I'll be going over that in a second. And then if you could have your warm-up in front of you. Warm up in front of you. Oh, yeah. So first question was to label the equation. We know that this is a linear equation. So if I go ahead and label it, Riley, give me a couple things I should label.
So 12 is the Y-intercept.
So this is my Y-intercept. Keep going.
Just the 4 is your rate.
4 is my rate, or what's another word for rate? Slope. Okay.
X is your Y-intercept, or your independent variable.
This is my independent variable, and that's important because that's the one I get more control over. I can choose a number to put in for that. Okay? And then,
Y is your dependent variable.
and this is my dependent variable. This depends on everything else. So that was step 1. What does that 4 mean? Yes, it's my rate. Yes, it's my slope. What does it mean? Like on a graph, what does it mean? Yeah. The rate of change. So explain to me how that would look.
So the rate of change, like how much is going up or how much is increasing or decreasing.
So how much increase or decrease, which means this. My rate is calculated, or my slope, change in y over change in x. So if I have a slope that's equal to 4, that means 4 over 1. So it means for every time on a graph, for every time I go over 1, I go up 4, make a dot. Over 1, up 4, make a dot. Over 1, up 4, make a dot. Over 1, up 4. So then I have this line. That's what that 4 means. It means over 1 on the x, I have a change of 4 on the y. And it's a positive 4, so it's going up. So then I have that. Let's give some coordinate pairs. Isaac, give me one.
The coordinate pairs I had was 16, 1, and 20, 2.
Okay, so wait. If I put 16 in, 16 times 4, 64. 64 plus 12, yeah. Uh-huh. I thought for a second, Isaac, I was like, man, he's really challenging himself. Good. So 16 and 76. So now, Isaac, give me another one that would be a little easier. What could I make my independent variable be? That'd be easy. 2. So if my x is 2, 2 times 4 is 8, plus 12?
20.
Maya?
I had 3 and 24.
3 and 24. What about if I asked you, what's the y-intercept coordinate point? David?
0, 12.
0, 12. Good. That's an important one to know because that's what we start with, right? When we talk about fundraising and stuff like that, we know that's where we start. So it's always a good one to put in. Put 0 in for x, and plus that's easy calculations, right? And that'll help you make your line. If x is 7, what does y equal? Talk your tables. And how did you do it? So this is basically my question here, Anthony. When it asks me if x is 7, what does y equal? I put 7 in for x, so my new equation becomes 12 plus 4 times 7. PEMDAS tells me do that first. That equals 28. Now I have 12 plus 28, and then I know y equals 40. So my coordinate point is when x is 7, y equals 40. Any questions about the warm-up? So if you notice, yes?
So the rate of change is like exactly the same as rate?
Yep. Yep, it is. If you notice, if you haven't read it yet, the I can statement for today, I can graph a line using the y-intercept and slope. What information does this equation give us? David?
The y-intercept and slope.
The y-intercept and slope. So I take all those coordinate pairs, and just like I did over here with that sketch, I'm able to make a graph. Really easy. And all I'm doing, Isaac, is I'm putting numbers in for x and getting out my y. Okay, I put it in for the equation. Tonight, unit test is on Thursday. I'll talk about tonight in a second. Unit test on Thursday. Prepare for it. This review will help you big time. Like 80% of the questions on here are pretty close to the questions you're going to see. So, and then there's that 20% that's where I want, like, even you guys that get this, I want you to have that productive struggle and try to figure it out. Tonight, your homework is this, James. It's the first page, the front side and the back. I normally don't assign this much, okay, but that's what you're going to have for tonight. It's like, how far did you get in, like, the 8 minutes you were working on it? Did you get, like, through half of this front cut? It might take you 30 minutes if you're. It's not going to take too long. Okay? But it is the front and the back. And if you do it, it's going to really help you because tomorrow we're going to have a little exercise around going over it. It's also on the internet. It's on the classroom. I've already scanned it and put it on there. So if you can't find it, you get home, go to the classroom. It's right there. Test grades. I put them in Infinite Campus this morning. So most of us on our test grades from Investigation 3 most of us in here got 2 points. So how'd you earn your 2 points? Well, you could earn 3 points, right? One way was show me that you tried to check your work, but you're still getting the wrong answer. That only happened twice. Because guess what happened when people checked their work? They ended up figuring out the right answer. So they didn't need the bonus point for that question. But there were a couple kids. Presley in the last class was one of them. She missed. I could see she was checked, and she checked 3 times to find the right answer. She put it back in, and it wouldn't work. Okay? So she ended up getting one of those bonus points because she was checking her work but couldn't quite figure it out. The other one was if you made a procedural mistake, which most of us in here did, you got a bonus point. And I could see where that procedural mistake was. And the other one was if we made a calculation mistake, which not everyone received 2, but on average there was a lot of 2s. So if you check Infinite Campus, you'll kind of see your grade. It should be higher. I think, Axel, you said you got 2 points. Yeah. So he had a 27, now he has a 29. So all because he's showing his work, which is really important. Which reminds me, you want to show your checking too. Yeah. Which you didn't on one of them, and I was surprised because I think if you would have got 3 points. Retakes are tomorrow. I'll be here in the AM at 7. So if you're interested in retaking, that will happen at 7 o'clock tomorrow, and then again on Wednesday at 7. Now, there's a number of you in here that did not pass. So you can come in on Tuesday morning tomorrow. You can come in on Wednesday morning. If you don't, then instead of hanging out with your friends on Wednesday, during the long lunch and recess, you'll be taking the test. That's always a choice. And Wednesday is going to be like 50 degrees. It's going to be like super nice, so it's not going to be cold. So you might want to think about getting that done. One more thing about that. What was it? You need to bring in your, I need to see if you're going to do the test corrections. And those of you that failed, I'll be grabbing you tomorrow during lunch to finish this. Okay? To make sure that that's done, because then on Wednesday, you're not going to be doing this. You'll be taking the test again. Online, you have a couple resources that you can use to prepare for it. You obviously have the test. I sent that to you. You can look that over too. Any questions about any of the announcements? Okay. Liam's over here. Taylor's over there. We're going over 8, 9, 10. Should only take a few minutes. Taylor is in. She is going to lead the discussion over there. Liam, we're later over here. Please get your homework out. Find your respective side. It's good work. Wow, that's interesting. You guys all, I'm looking at your 29s, and I'm going to go over this.
29?
Yeah, it was the time, we didn't check it, remember? Last week on Thursday.
Oh.
And it's interesting, oh, you guys missed it.
Wait,
Excellent.
what? I did? Well done.
Let me see if you
Wasn't
did.
that from a really long time ago? This one?
Mm-hmm.
What was it supposed to be?
I don't really remember.
You almost had it, Lulu. You're the closest.
What was it supposed to be?
I'm going to go over it. Where's your 29? Yeah! Axel! Axel got it.
We all got the same answer.
You guys did?
Yep.
James, is yours good too? Jacob, did you check yours?
My score was better.
David, are you doing yours or?
Yeah, I got it.
Okay. All right, guys, grab your stuff, head to your seats.
Did you check me yet?
I checked it. Thank you, boss. Okay, can everybody turn to, really impressed with your homework. If you guys could turn to 103 in your book. 103, 29. All right. So this was from the night before. Okay, this was homework that I assigned on Wednesday.
What happened? Yeah, that.
Okay. See if this will stay. All right. So it asks you to find the slope of the line. Now, so this is my book, so I get to draw in it. Change over y over change in x. Okay. And so I picked this point. What's this point right here? I love 0, 0. So easy. So I picked this point because, again, it's right on an intersection of line, right? So I come over. If that's 6 and that's 4, what's this? 5. So what's the change on my y from here to here? 5. And it's positive 5.
5.
Okay? And then I come down. This is not 1.
It isn't?
1 is here.
It's 10
I
times
made
5.
that. I was confused about nothing.
It's 0.5. So this is 0.5 change, positive. And just like Max said,
10.
that's a slope of 10. 5 divided by 0.5 is...
Wow.
So I can tell you, we didn't necessarily make many errors in our change of y and change in x. Our error was realizing that this is not 1, 2, 3, 4, 5. You got to pay attention to that scale, right? Scales on every graph change. And as advertisers, like when you see like a graph like on the news or like on Instagram or not Snapchat because no one Snapchats it, but when you see like a graph, pay attention to the scale, because the scale, I can make a graph look a certain way by changing its scale, and sometimes it looks really steep and it's like, wow, man, people are spending a lot of money, but then you look at the scale and it's like, it's not by ones, it's by like 0.1.
They're spending this much money.
Yes, and it looks super steep, but the scale tells you, wait a minute, they're really not spending that much money. Taylor.
So I'm still kind of confused how you know if it's negative or positive. Like,
Okay, how do I know if it's negative or positive? If I find a point, I find this point. If I go from here to there, which is where this one is, from here to there, 0 to 5, is that positive? Now I'm here. If I go from here to here, am I going in a positive direction? Yeah. Now watch this. If I'm here and I go from here to there, is that positive? No, that's going to be negative. That'd be negative 5. And then if I'm here to here, is that positive? No, that's negative. That would be negative half. But what's a negative divided by a negative? Positive. So what matters is that you follow your flow.
so could you go the other way though? Could you?
Go this way?
No, go like. Never.
Hold your thought. All right, today, please put in front of you 4.3. Wow, look at that line I drew. I know, what a great box it is too. Whoops. Oh my goodness. My eraser was drawing. Okay.
Wow.
4.3. So one of the recommendations from you guys on Thursday was to do a little bit more direct instruction before you do your independent practice. So I'm going to do this pretty quick today, because I feel like you guys are pretty good at this learning target already. The learning target is, I can graph a line using the y-intercept and slope. We just had an equation, 12 plus 4x equals y. 12 was the y-intercept, 4, and we got these numbers. But we're going to practice using a table, creating an equation. So my standard form is y equals mx plus b, and I want you to follow along with your notes. So I've got this y equals mx plus b. Label the rate and the y-intercept on your equation. These are the 2 points that I really need. I need to know these 2 things if I'm going to graph a line. I need to know what the y-intercept is, and I need to know what the rate is. Well, how do I figure out a rate? What's the formula? Change of y over change in x. So here I have my table, and I'm going to figure out change of y over change in x because that is going to tell me the slope of this line. So here I have a change of 1. Here I have a change of 3. How many points do I need to check? Oh my goodness. I need to check 3 points, right, to make sure that my line is linear. Okay, so go ahead. At your tables, check it. Go. Hi. No.
For every
Jackie.
y,
Oh, nice to meet you, Jackie.
Graham, she was the assistant soup in Sheridan for years when
Come
I
down
was
here
there.
and see if we can get some money for Salina.
And Daryl,
Yeah?
Carol's a superintendent, is my husband.
her husband.
Oh, okay.
Have you been here?
Yes and no. I was here for 8 years and then went overseas
Okay.
and then came back. And I was in the valley for a little while, but I was up valley, up in BB.
Did you work with Sue Holmes? Yeah, I lost track of her. Good friend.
She's high power
I know
in
she's in Falcon, but
yeah,
I
in
sent her-
Falcon.
It was funny. Even yesterday, I sent.
I just communicated to her like not long ago.
Please, Jackie Webb.
Yeah.
Tell her my cell phone's still the same. Tell her to text me. I'd love to get together.
Sue and I jam, man.
I love her.
She- All right. So what do we find out? Is it linear? Yeah. All right. So we got change of y over change in x. So here I have a change of 1 over a change in 3. So I get the slope of 3. What does that mean?
That's our rate.
That is our rate. That's our slope. But what does it mean? For every time I go over 1, I go up 3. And it's important to understand that that's what that means. That this unit rate is a 3, which means over 1 of my x, up 3. So where do I put that 3 in? Well, I plug it into my rate. So now I have this. Still not there because what do I need? Look at the table. Do I have a coordinate point that tells me my y-intercept? Max?
0.
So when x is 0, what is y? 3. So now I plug that in. All right. So I've got my equation. Thank you. Boom. But now I want you to tell me what are 2 more points that I could add to this table. 2 more coordinate pairs that I can add. Okay? I know if I put in 4, I'm going to get 15. Yeah, great. But what are 2 more that I don't know? Go, work at your groups. Max has already got one. No, you don't have to. So Max, you said 5 and 18. So this is what he did, Jacob. Max took 5. He put 5 in for x. 5 times 3? 15. 15 plus 3. So he gets that. What would be another one? Anthony, what would be another coordinate pair? 5 and 18 work because if I put 5 in, 5 times 3 is 15, plus 3 is 18. So when x is 5, y is 18. What would be another one? I've gone from -1 all the way up to 5. What could be the next point here I could check? -2. Oh, I like it. -2. We're going to put it down there. Oh, he's throwing. I love it. Anthony's throwing curveballs. So here we go. -2. -2 times 3 is -6. -6 plus 3? -3. Nice coordinate pair. I like that. All right. So that's your job for today. Your job is you're going to need to use equations which have the slope and y-intercept, and you're going to find these coordinate pairs. And the pairs are here, right? This is where I would plot on my graph. Questions? Yes?
I'm just wondering, why isn't the y-intercept 0? Because the graph starts with 0.
X is 0.
If I put 0 in for x, what's 0 times 3? 0. Plus 3? 3. So that's, I guess, does that answer your question, or am I not answering it? What the y-intercept is always 0 something. Sometimes if it's proportional, it's 0, 0. Right? Proportional means I put 0 in, I get 0 out. That means it goes right through the middle of my graph, right? It has the same amount of space on below as it does above. Any other questions? All right. Today, we're going to be jamming with page 94. You are doing A1, A2, A3. Only do group 1. Okay, don't do group 2. And then you're going to go B1, B2, B3, but only pair 1. And this is independent. Okay, once you finish those, which some of you will, then you'll go to the NPS. Which is, if you've done the vocab sheet, you're going to do problem 12 on page 99. As you wait for a partner. Questions? All right, we be jamming? All right.
Run away.
How rude.
Yes.
Yeah. Only group 1. Right, no, you're not comparing group 1 to group 2. You're comparing all the equations in group 1. Okay? So when they ask you to compare, you're comparing all the equations in group 1. You're not comparing group 1 to group 2. You're looking at all the equations in group 1 and you're comparing them.
After group 1, do we go
Pair-
do A1?
A1, A2, A3, yes.
Okay.
Or just group 1. Yeah, and I gave you graph paper on the back.
Wait, do we consider
Homework. That goes in homework. Good job on that one. You did a good job on that one. Graph this, and this. All, yeah, all in the same one.
Yeah, then we got the all in like one graph.
Yeah, you graph all of group 1 on one graph.
Oh no, it's 14 or 14.
Wait, we actually don't have to solve those equations? Can't solve them. How do you graph it if you can't even solve it? Are we supposed to graph all those?
You're supposed to graph all of group 1.
All of those. We can't
have in it.
Well, what you do is this is where you get the coordinate pairs. So you would put in an independent value. So let's say you put in 1. What do you get for y? And then you do 1 here, 1 there, and 1 there. And you're going to get different points, right? But all the graphs will be on the same set of axes. Yes. That's it. You got a 13. Where did it go? Let me look at home. I graded it. I graded it. Oh, so you know how like group 1 has a certain pattern? You need to create a group that has a pattern.
Okay.
Does that make sense?
Does it have to be like awesome?
It could be a different pattern. That'd be good. That'd be cool.
Like a different, same Y-Intercept?
Could be like that. Yup. Yup. I'll be right there, Lily. Hold on.
Do I graph them or just write?
You didn't fill this in yet.
Do I graph them or write the equation?
You write the equation. Over 1. Yes. That's what it means. Yep. So then you're going to graph, now you're going to graph that one. No. That's good enough. Oh, so that would have to mean that it'd have to have the same, not the same rate pattern, but you'd have to create a group that would have the same rate. Does that make sense? Because the pattern that you're looking at does have the same rate. Be right there, Axel. Okay. Yep, just keep now graph the other ones.
Yeah.
Wait, you're doing it backwards. You're going up 1 over 3. It's over 1 up 3. Right? Because if the rate is 3, which you said it is.
Oh yeah, I knew that. I just didn't get it. Oh, sure. Well, I was maybe.
Boom. Okay, so you have a group, right? And that group all has a certain pattern, right? So you need to create another group with a different pattern, but the same kind of pattern. So what does that mean? You're going to make a bunch of linear lines, and what are they all going to have in common? Yeah, the slope. They're all going to have the same slope. Just like, but you don't need to graph them. You just need to create 4 linear lines that have, yep. You need to create 4 equations that are linear that have the same slope. Nice, Riley. You need help with this?
No.
Are you confused about anything?
I'm just trying to, I was making it way too big and I was making the x-axis in front of the y-axis.
Oh. Yeah. Yeah. For literally, Max, all you really need to do is, boom, you got it. Yep, that's smart. A3? Ah, yes, good one, isn't it? Wow, that'd be deep, man. So sometimes what is common is what is creating the difference. Does that help? So, okay, so the first pair had the same kind of rate, right? Slope. Do these?
No.
Tell me, what do you notice about their slopes?
Well, the second one is half of the first one, I guess. Like, this one is, well, it's going down and the other one's going up.
Okay. So one's positive, one's negative. Okay, good. What else do you notice about it?
Well, this line is going up faster than this one's going down.
Okay. So how about if I, so you notice that one's positive, one negative, and then one's being multiplied by 2. What's happening to the other one?
It's being divided.
By 2. So what do we call things that one's positive, one's negative, one's being multiplied by 2, one's being divided by 2? What are those called? That's the commonality. So what is common is actually what they share in common is actually what is different about them. They're inverses. That's what's common. Does that make sense? Like they're literally pair 1, they're inverses of each other. One's positive, one's negative. One's multiplied by 2, one's divided by 2. Those are inverse. It's hard to see that. Yeah.
Figure out E3. What is it? Like, what is it asking? It's describe another group of ones.
I'll be right
that have
there.
the Same pattern.
Right. Okay. So we recognize that in group 1 they have a pattern, right?
Yeah.
Can you create a group that has a similar pattern, but not the same exact number pattern of group 1? Could you create a group of equations, of linear equations, that have the same kind of pattern?
Yeah.
That's what they're asking you to do. Yep. Yeah.
So, this is the x-axis.
Yep.
Wait a second.
What you?
So then, but then wouldn't it be going over 3? Because that's it.
No, because it's change of y over change in x.
Oh, that makes sense now. Because then 3
Over
times
1, up 3.
2 times 3
And another way to remember it is that it's rise
over run.
over run, right? And rise means to go up, run means to go across. Does that make sense?
Yeah.
And so that will help you remember which one's which.
Can I do this?
Yeah, they're not exactly perfect because it looks like they're getting a little closer together,
Yeah.
which I'm not sure why. But yes, they should be parallel to each other. You know why? Because they all have the same rate. So they're all parallel. Yes. Number 3, so you know how group 1 has a bunch of, has a pattern?
Yeah.
Okay? Create your own group of equations with the same kind of pattern. David?
B1 is confusing.
Yeah,
Like, I don't see.
that's hard. So what do you notice about those 2 equations?
One's positive.
One's positive, one's negative. What do we call that?
Opposite.
Opposites. What's a more mathematical term?
Inverse.
Inverse, okay? What else do you notice about? There's only one other thing to notice. One's being multiplied by?
By x.
No.
By 2.
2. And what's the other one?
Being divided by 2.
What is that?
An opposite.
Opposite, inverse. So that's the commonality, is they're inverses. So like it's almost like finding a common difference. Okay?
All right.
Yeah, Taylor.
Oh, I'm just gonna. What does the rate go on the bottom?
Jacob, you focus. He can waste his time. Don't waste yours. Okay.
Does the rate go on the top or the bottom?
The rate?
Yeah. Is that what that is?
So this means change of y over change in x. I don't know if that helps you.
Yeah. Okay. Sorry.
Does that help you?
Yeah.
Okay. Okay, let's go ahead put away our work for today. We'll work more on this tomorrow. So, one of the things I said I would do is, and this can happen more tomorrow, because I didn't see anyone do it today, but check your answers. I said I would do that. I said I would remind you, so I'm kind of reminding you at the end, but I highlighted it as a reminder for myself. But tomorrow, please check your work. Like, yes, I talked to some of you, I met with you. That helps, but check your work. You need to make sure you're doing it correctly, Isaac. Okay, so make sure you do that tomorrow. The answers are right over there. Your homework is the front and back of the sheet, the review sheet you grabbed. That's your homework. Like I said, plan on it taking 30 minutes.
Like the front and back of the first page.
First, it is the whole first page, front and back.
Oh.
Yep. I can graph a line using the Y-intercept and slope. That's what we did today. You had equations that had the Y-intercept and slope, and they were asking you to graph them. I put a value in for my independent variable, and then I get out a dependent variable value. Write down one thing you learned today. Restate the question. Max, exit ticket. One thing I learned today was, and make it mathematical, if you want any credit, and make it specific. I will be collecting the warm-up and exit tickets on Thursday while you're taking the test. So you want to do a good job on these. Axel.
Mine's kind of confusing because I accidentally did the stuff on Wednesday. Once I changed the Wednesday to Monday.
I'll figure it out. As long as you labeled it.
I did.
Looks like Miller's going to need an NPSS tomorrow. She needs a partner. Do your review sheet. Stay on top of your warm-up and exit ticket this week because, again, I'll be collecting those on Thursday for sure. Other than that, have a great evening. Chairs pushed in. Calculators put away, please. Pouches hung and zipped. But not here. Oh, as you say. Confusing me, Lulu.
I'm always confusing people.